A treatise on algebra, containing not only the fundamental principles of this art, but likewise a variety of problems in the most important branches of the mathematics, with new and interesting rules for finding the roots of equations and for determining the lengths of curved lines, etc. By German Buxton, London. Printed for the author and sold at No. 2 Church Street, Soho, also by Sherwood, Neely and Jones, Paternoster Row, 1819. Preface. The mathematical sciences in all ages have deeply engaged the talents of the most learned men and been considered useful preparations to the sublimest studies. Several excellent treatises have already been published on the fundamental branch of those sciences, namely algebra, in most of which may be found various methods for finding the roots of equations. It is well known, however, that those methods are such as are either attended with a great deal of trouble and labor in preparing them for the operation, or else confined to particular cases, and it is from this consideration I have been induced to undertake the following work, and from the general rule contained therein for approximating the values of all unknown and required objects, being a perfect remedy for all former defects as far as regards this part of algebraic science, am in confident expectation of its being well received. This improvement, if duly attended to, will be found of great advantage, inasmuch as there will be no necessity for having one rule for finding the value of the unknown quantity contained in a quadratic equation, another for reducing a cubic equation to a quadratic, a third for finding the roots of equations by the tedious method of converging series, and so on, the whole being happily brought under one general rule, whereby such value may be approximated to any degree of exactness required, with the greatest facility and expedition. It is of importance, moreover, to observe that the same rule which serves for finding the roots of equations serves also for reducing a maximum or a minimum to an equation, and consequently the tangents to curves, the lengths of curved lines, the areas of curvilineal spaces, the surfaces and solidities of concave and convex bodies, or the heights or distances of inaccessible objects from the earth's surface or center, etc., may all be obtained by geometrical construction and algebraic calculation. It is true, these new methods of calculation have been carried no further than the circle, but enough is given to show the great importance and use of them. I have assumed the liberty of wholly departing from all former writers with regard to equations, having brought them under two heads, namely simple and compound. That is to say, those which contain only one unknown quantity are called simple equations, and those which contain more than one are called compound equations. Most of the problems contained in this work produce such equations as call forth the new rule for determining the values of the unknown quantities contained therein. These had a preference in order that the learner might have a greater variety of examples to exercise upon. It is highly requisite, however, that he should be well acquainted with geometry before he undertakes the solution of problems in the higher branches of mathematics. Otherwise, the knowledge only of finding the roots of equations by approximation will be but little or no advantage to him. The duty of every author upon the sciences should be to put the young and unassisted beginner in a path where he will meet with the least possible obstacle in his pursuit after mathematical learning. And if it should be thought I have been instrumental in favoring this design, all I solicit of the reader is, that he will make such allowances as every inventor of a new subject is entitled to, and candidly pass over any defect which he may discover, and which may have escaped the observation of him who has the honor of subscribing his name, German Buxton.